question is from the 2015 exam. It's number 5. We have a function, specifically we have a picture of the graph of f prime, which looks like this, and it's twice differentiable. Has horizontal tangents at -1, 1, and 3, so that's where we can see possible relative maximum and minimum values. They also give you the areas of different regions bounded on the graph. I think I'm going to go ahead and mark those in right now. Between -2 and 1, that region has an area of 9. Notice it's in a negative region here, so I'm going to mark that as -9. Let's see. And the interval from 1 to 4, they say that that area is 12. Again, it's a negative region, so I'm going to write a -12 in there, but got that. All right. Part 1 asks us to find all x coordinates at which f has a relative maximum. I think I'm going to put together a number line here first of all. I think that'll be kind of helpful. Number line for f prime. Remember, we care about places where f prime changes signs. So where f prime is 0 or undefined, those are potential critical values. So notice -2, 1, and 4 are places where f prime is 0. So f prime is positive up to -2. That tells us the original function was increasing. F prime is negative between -2 and 1. Tells us the original function was decreasing. And f prime actually is negative again between 1 and 4, which tells us the function is actually increasing yet again in that interval. Part A asks us to find all x coordinates at which the graph has a relative maximum. So remember, a maximum occurs when a graph goes from increasing to decreasing. So that would be a positive derivative to a negative derivative. So if you look over here, a positive to a negative happens just at x equals -2. And I could say something like at x equals -2 because f prime changes from positive to negative at x equals -2. And we never see that positive to negative happen anywhere else. You do have a plateau point at x is equal to 1. You can see the graph is decreasing, and then it levels, has a derivative of 0, and then it decreases again. So not a relative maximum or minimum. Part 2. On what intervals between -3 and 4 is the graph both concave down and decreasing? Give a reason for your answer. So concave down would be a negative second derivative. Decreasing would be a negative first derivative. So I'll go ahead and put together a second derivative table here for f double prime. Now, that's a graph of f prime. F double prime is going to be the rate of change of f prime. It's basically just the slopes of that. So notice this is f prime, sorry, the slope of f prime, which is f double prime, is negative from -3 all the way down here to -1. So that's a function that's concave down. It's positive from -1 over to 1. So it would be concave up. And then it's a negative slope from 1 to 3. So it would be concave down again. And then the slope is positive from 3 to 4. And it's going to be concave up again. So we want all the places in which f is concave down and decreasing. So it's negative first derivative and negative second derivative. So we're looking at values between -2 and 1. But the only place where negative there is up to -1. So from -2 to -1, we have those places. So -2 to -1. I guess I could just go ahead and write that down. Let's see. That's part B. X is between -2 and -1. And let's see. Let's go back here. So negative graph, it's got a negative slope between -2 and 1, and then again to 4. So anywhere between -2 and 4, that's negative here. And that's going to be at between 1 and 3. So X is between 1 and 3. And by the way, technically it's not concave down or concave up at the endpoints there. Those really should be less than symbols, not less than or equal. Okay, part C says find the x-coordinates of all points of inflection for the graph of S. Give a reason for your answer. Inflection points happen when the second derivative changes signs. When you change from concave up to concave down, or the other way around. So that happens here at -1, happens here at 1, happens at 3. So part C, it's happening at x equals -1, x equals 1, x equals 3. These are locations of inflection points because f prime changes signs, f double prime changes signs. At these values of x. Okay. And then part D. They tell us an initial value here in part D. They tell us that f of 1 is equal to 3, and they asked us to write an expression for f of x that involves an integral. They want us to find f of 4 and f of -2. So they're giving us a starting value of f. We have this initial value at 1, 3. This is f prime. So to get back to f, we need to take the integral. Remember, though, that when you take the integral, that only tells you the change over that interval. It doesn't incorporate initial values. So I want to incorporate my initial value here. My function starts out at the point 1, 3. So when x is equal to 1, the function is equal to 3. So 3 plus any change that's happened from an x value of 1 to whatever that x value is of my derivative function. Now, I'm not going to make this f of x. I'm going to call this f of t. The input is going in as a bound. So if I want the functional value at 5, I'm going to sub in 5 here and then take the integral between 1 and 5. If I want the functional value at 10, I'm going to sub in 10 there and find the integral between 1 and 10 and then add 3 and so on. So that's my f of x function there. They want me to find f of 4. So f of 4, of course, is going to be 3 plus the integral from 1 to 4 of f prime. And the integral from 1 to 4, of course, is -12. So 3 plus -12 is equal to -9. There's that result. And if I want to find f of -2, I can sub -2 in there. Now that's going to be going from 1 to -2. That's going backwards. So I'm going to switch the bounds. I'm going to have it go from -2 to 1. Sorry, that's a 1 there. And I'm going to change the sign to negative. So the integral from -2 to 1 is -9, but we're taking the opposite there. So minus a -9 ends up being a plus, and we get a value of 12. Okay, so let's take a look at the answer sheet. Let's see how we did on this. Let's see. First part there, we get 2 points for f prime being 0 at -2, 1, and 4. Relative maximum at x equals -2. Part B, concave down and decreasing on the intervals between -2 and -1 and 1 and 3. Because f prime is decreasing and negative on those intervals. So you could say f prime is decreasing, or you could say f double prime is negative. Either one is the same. Part C, point of inflection at x equals 1 and x equals 3, because f prime changes from decreasing to increasing at these points, or you could say that f double prime is negative Oh, because f double prime changes signs at those points. And then the last part here, you have the integral function, and you're subbing in the different values, and you get -9, you get 12. So looks like perfect 9 out of 9 on this one.